Hi everyone! In this new tutorial, we're gonna make a very simple script to control the movement of a game object to reach another one and follow it smoothly. Alright, so starting with a new scene, I just have here a capsule, a camera, some post-processing effect. I'm adding a sphere, which is the object we'll want to move through the script to reach the capsule. Let's start a new script. Call it smooth reach target. We can remove the start method. We'll register a target and also a speed in order to control the movement. Then in the update method, we'll check if the target is null to avoid errors when in play mode. And then we calculate the current direction from the object to the target. And we simply increment the position of the object using this direction vector over time using the speed variable. Alright, now we have to add the component to our game object. Then we want to reference the target, which is the capsule here. And here it goes, straight in line. We want to simulate some kind of inertia. So we'll suppose we already have some velocity on the forward axis. So what we'll do is move the object in his forward direction and apply a small rotation each and every frame to face slowly the target. So here it's not slow at all, it will rotate in one frame. So we're adding the current direction as a private variable, and then we lerp the current direction over time. We're going to use a new public variable, turn smoothing, in order to control the amount of turn we can do in one frame. Now we don't want to assume that the movement will always be on the object forward direction, so instead we are using the current direction and leave it up to the current direction initialization. Alright, so now we are going to clean things a little bit by creating a public method that will initiate the movement, specifying as parameter the target, but also initializing the movement direction. Now, for testing, we'll add an enable method that will call this function. Now, I also want to add some more control over the speed and the turn smoothing. So I'm going to add two animation curves. Now, for the animation curves, we need some kind of ratio. I've chosen the current distance over the starting distance, but you could be using the time or whatever you see fit. So I added a private starting distance variable to keep track of the starting distance, and each frame I calculating the distance ratio and using it to evaluate the speed curve and the turn smoothing curve. And since it's easier to define a curve between 0 and 1, I'm multiplying the result by the speed and turn smoothing variable. Now, for the same reasons, but on the time axis of the animation curves, I'm clamping also the distance ratio. So after setting up the speed curve and turn smoothing curves, you can achieve some very different results playing around with the speed and the turn smoothing. For example, here with the turn smoothing, the closer we are to the target, the less smoothing we will have, which can be very useful if you don't want your object to follow a moving target too quickly. And on the speed curve, as we can see here, the closer we are to the target, the faster it's gonna be, which can give a gravitational feeling. Then it's all about experimenting. For example, here I added 3 particle systems with a smooth reach target to a sphere that itself is following the capsule. And as you can see, we have already a smooth movement, giving a pretty nice result. From there, you can easily add some features to this script. For example, 2 events on start on reach methods. And this is all for this video. You'll find the script on the GitHub link, as well as an extended version using Odin Inspector. I hope you enjoyed the video. Please subscribe for more videos or news and updates on Machine Tail development.